Another method of finding the determinant of a matrix is by using the pivotal element method. So let A equal to Aij be an n by n matrix. So choose a pivotal element Aij which must be equal to 1. Okay, the pivotal element must always be a 1. In the case we're in, there is no such entry in your matrix. Say you want to find the determinant of 4, 8, 17, negative 3, 2, negative 6, 0, 5, and so on and so forth. Okay? And you want to use this as your pivotal element. Now, the determinant will be the same if you'll factor 2 from the elements along the second row. You retain all the other entries, 4, 8, 17, negative 3, and you factor 2 from the elements along the second row, so that will be 1, negative 3, 0, and 5 over 2. Okay, in that way, you will now have a pivotal element that is equal to 1. The determinant of A is given by the determinant of A prime, where A prime is the n minus 1 by n minus 1 matrix obtained from A by deleting the ith row and jth column of A and subtracting from each entry the product A, I, S, A, R, J. Okay, so we subtract from each entry A, R, J the product AIS, ARJ. So you choose the pivot Aij that is equal to 1, delete the ith row and the jth column. And for each remaining entry, ARS, you will subtract the product AIS, ARJ. There. The pivot is Aij, and from each remaining element ARS, you subtract AIS, ARJ. So let us have an example. Okay, so let us choose our pivotal element. Let us say this one. Okay, this will be our pivotal element. So the determinant of A is equal to, we delete the first row, fourth column. Alright, by the way, there is a factor. There is a factor of -1, no? In the definition of the determinant. -1 raised to I plus j times the determinant of A prime. Okay, so that will be -1 raised to, our pivot is along the first row, fourth column. So first row, fourth column. Then determinant of. It is a 4 by 4. So after deleting row 1 and column 4, it will be a 3 by 3 matrix. And for each remaining entry, we will subtract the product of A, I, S, A, R, J. So in this case, we start with 2 and then we subtract the product of 3 and -3. Alright? We subtract the product 3, -3. Okay? So we go to 0. We subtract the product -1 and -3. So -1, -3. Okay. Then 4. 4 minus the product of 2 and -3. Okay, next, -3 minus the product of 3 and 2. -3 minus the product of 3 and 2. Next, 1 minus the product of -1 and 2. 1 minus the product of -1 and 2. Then 0 minus the product of 2 and 2. 0 minus the product of 2 and 2. Next, 2 minus the product of 3 and 1. 1 minus the product of -1 and 1. 1 minus the product of -1 and 1. Finally, -3 minus the product of 2 and 1. -3 minus the product of 2 and 1. So -1 raised to 5 is negative. Determinant of 2 plus 9, that will be 11. 0, negative, what is this? -1 and -3. Okay, so that will be -3. And then 4 plus 6, that will be 10. Next, -3 minus 6 is -9. 1 plus 2, that will be 3. 0, -4. 2 minus 3 is -1. 1 plus 1 is 2. Negative 3 minus 2 is negative 5. Okay, since this is a 3 by 3, we use the basket weaving method. So 11, 3, and negative 5. What is the product? Negative 165. Okay, then minus 12 minus 180 plus 30 plus, what is this? 45, 135. Okay, plus 88. Again, 11 by 3 by negative 5 is negative 165. Negative 3 by negative 4 by negative 1 is negative 12. 10 by negative 9 by 2 is negative 180. Minus negative, so that will be positive 30. Minus negative, 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 that should be positive. No? 27 times 5 is 135. Minus 11 times negative 4 times 2, that's again positive. Okay, so what do we have here? Negative 165, negative 12, and negative 180. That will be 7, 15, 357. Okay, so let me see. 165 and 12 was 177, 357. Okay, 30 and 135 is 165, and 88, that will be 253. Okay, negative 357 and 253, that will be 40, negative 104. Okay, so 357, 253, 40, negative 104. Negative and negative, that will be positive 104. As you can see, now, in this method, the matrix, originally 4 by 4, is reduced to just one 3 by 3. Compare this to the cofactor expansion method or to the Laplace expansion method, no? Wherein a matrix is reduced by one row and one column, but it produces several submatrices. No? So, in the cofactor expansion method, if you have a 5 by 5 and you expand about a row, you will be creating 5 4 by 4. Okay? And you can evaluate a 4 by 4 by basket weaving method. So you have to reduce each 4 by 4 into 4 3 by 3. So all in all, you will be producing 23 by 3 coming from a 5 by 5 matrix. Alright? In the Laplace expansion method, if you have a 5 by 5 matrix, and you are to expand about 2 rows, you'll be using 2 columns. There will be 10 combinations of 2 columns from among 5 columns. Okay? So it will be a product of, there will be a product of a 2 by 2 and a 3 by 3. And there will be 10 such products. No? There are 10 combinations of 2 rows and 2 columns. And it will be associated with a 3 by 3 matrix. And these combinations of 2 by 2 and 3 by 3 matrices or determinants will involve about 10 addends. Alright? Whereas for the pivotal element method, if it is a 5 by 5, it reduces to a 1 4 by 4, which we can further reduce to just 1 3 by 3. So far, the pivotal element method offers the easiest or the shortest way of finding the determinant of a matrix. Right? So will you try finding the determinant of the given matrix?